Okay, so here is our question 4. So question 4, it says a learner is test. Okay, a learner tests the strength of a piece of glass by dropping a steel ball of mass 5 kg from a height of 3 meters. Okay. The velocity time graph below represents the motion of the steel ball from the moment the learner drops the ball until it reaches the ground. So here, this is the ground. This is where, okay. So now, from the moment it drops it, okay, here it is dropped. It's like we are having a glass here, a glass somewhere here, and the learner drops a ball, okay, and that ball, remember, if it is dropped, it's going to have a velocity of 0 initial. And then what's going to happen is that the ball is going to break into the glass. Okay, it's going to break into the glass and it's going to move downward. Now it's going to move downward until it reaches the ground. Okay, so yeah, this is what's going to happen, guys. This is the scenario thereof. So now we are on 4.1, we are asked define momentum. Now it's easy because the momentum is just there. The product of an object's mass and its velocity. This is supposed to be 0 or nothing, guys. You get it correct or not? Now 4.2. Calculate the net force exerted by the glass on the steel. So let's interpret this. This is still in the motion, okay? Still in the motion. Remember, as we move downwards, the velocity increases because gravity is pulling the ball downwards, right? It increases. But this one, what happens? This is the collision. This is during the collision. This is before the collision. This is after the collision. So we are interested in knowing, calculate the net force exerted by the glass on the steel. So remember, the net force was exerted during the what? During the collision. Okay, this is during. So we might say, okay, the net force, I might calculate using impulse. Okay, and then I'm going to choose up downwards as positive because it's moving downwards. And then I'm going to say my F net is unknown. But what was the contact time during the collision? The contact time during the collision was 1 minus 0.8. So the contact time was 0.2. The contact time was 0.2. And then my change in momentum, I know it is my mass and then V final minus VF. Okay. I can say this is F net. Let me edit this. 1 minus 0.8. And then this is mass minus VF minus V initial. And then my mass thereof, they told me that it is a 5 kg steel. And my V final, okay, my V final, it is now the V after the collision. Okay, this is just after the collision. And then this is the V before the collision. So this is the V initial before the collision, and this is the V final after the what? After the collision. Okay, so I'm going to say my V final, it is 1.53. My V initial, is 7.84. Okay, I know it is not drawn to scale, by the way. It's not important. What's important is the concept. Therefore, my net force, I get to be something like, it's going to be negative, okay? Because I'm going to explain now why it is negative. So it means my F net is going to be 157.75 upwards. because I choose downwards as positive. Now, guys, if I'm moving towards the class like that, the force is gonna exert a force on the class moving downwards again. So the force is gonna react by moving. The force is gonna exert a force on the block upwards. So the ball, the steel ball exerts a force, a downwards force on the glass, but the glass will exert an upwards force on the on the ball, the off. So hence now we are saying it is upwards. And they say what? They said calculate what? Calculate the net force. Net force. They did not say the magnitude. So the net force. So this one, it is just true or nothing. It's either you get it correct or not. And then here it is the formula, the substitution, and then for you realizing that the contact time it is this, and then with your upwards like that. I think this was one of the nicest question. Just needed you to know how to interpret the graph like that. And then let's see the follow-up question. Open 3 says, is this an elastic or an inelastic collision? Refer to the data in the graph and relevant principle to explain the thing. Well, 4.3, it's clear. It is an inelastic in a why is that? In an inelastic collision, okay, let me talk about the elastic collision. In an elastic collision, the velocity final initial is going to be equal to the velocity final. So it means if this one, okay, it was not going to break, it was going to go there and move upwards with the same velocity. But now, since now the velocity initial is not the same as the velocity final, the off, during the collision. Therefore, it means now there was an energy lost, okay? There was some velocity that was lost there. Remember, if energy is lost in the form of sound, heat, and all of that, okay? And now it is inelastic. Why? Because now the velocity decreased, okay? It is inelastic because now the speed or the velocity, okay, before the collision is greater than the what? Than the speed after the collision. Or what you can say in simple terms is that V final is less than V initial. Okay, so it tells you that there was a velocity change. Okay, there was a loss of velocity. Okay, and then if now the velocity decreases, what happened to the kinetic energy? So it means the kinetic energy will not be conserved. Okay, so it means the total kinetic energy is not conserved. What do I mean by that? It means now the kinetic energy initial is not equal to the kinetic energy final. Hence, now it is not an elastic collision, but rather an inelastic collision. And then on 4.4, they ask us the glass does not break when the learner drops a soft rubber ball of similar mass from the same height. Okay, now remember the first one. The first one they used what? A steel ball. Okay, a steel ball has much force. Okay, a steel ball has a greater force. Okay, but this one it is just a rubber ball, so it has a less what force. Okay, this is practical because if you are playing with a golf ball, let's say you are playing with a golf ball. Okay, if they were to accidentally hit you with a golf ball, well, it's gonna have a much effect as compared to a created ball of plastic, but with the same mass. Okay, so as answering 4.4, Okay, here I think we can accept proving using calculations. Yeah. And then on 4.4, why the question is use physics principle to explain this phenomenon. Which phenomenon? The phenomenon that says when a soft ball is used, the glass does not break. Okay? Why? Why? It's because now, and again, you need to consider the what the the what is this? The time. Okay, a golf ball is heavier. Okay, is heavier, even though it has the same mass. It is heavier than the what than the rubber ball with the same mass. Okay, so this will cause the the soft ball to take longer time to reach you. Okay, if you are dropping a soft ball, well, since well it does not have a greater mass, can you see? Let's say P is equal to mv. So I know the mass is the same. Yes, the concept is the same. The mass, okay, they say what? The mass is the same. Yes, the mass is the same. But since well, this one it is a steel and this one is the rubber. Okay, and the steel and the rubber, even though their mass are the same, but now the what? They're gonna be heavier. Okay, the steel ball is gonna be heavier than the rubber ball. Okay, and then for that we'll say okay, so it means the rubber ball will take more time. Okay, will take longer time. I don't like how they put this question. Longer time to stop as it is soft. Okay, as it is soft. Okay, that's the first bullet. The second bullet, I'm gonna say, according to what? F net, it is equal to change in P divided by change in time. This is Newton's second law in terms of momentum. Okay, provided that the change in momentum of both balls is the same or is constant. I want you to see this. Now, if the rubber ball will take longer time, it means now change time is increasing again. If you take a longer time, it means your change in time is great. And then if I increase the change in time, remember this one is constant. If I increase the change in time, what's going to happen to the F net? The F net is going to decrease since F net is inversely proportional to that. Or here you can say F is inversely proportional to the change in time, provided that P is constant. It's very important that you mention that P is constant. Again, and then what's going to happen? Therefore, the force needed to stop the rubber ball is small enough to do what? Is small enough to the glass not to break. Okay? Or you can say force is okay, the force is not enough to cause a break on the glass. So the most important part is that the rubber ball will take longer time. Okay, will take longer time. And then, according to this one, provided that the change in P of the ball of both the balls is the same or is constant, another mark, then the force to stop the rubber ball is small. Okay, is small enough. Is small enough. Then another mark the off. I think that's how the marks should be allocated for this question. So let's move on to question 5. Let's move on to question 5 and see what question 5 holds for us. These questions were nice and genuine.